Good morning. Nanoscience and technology have advanced by leaps and bounds in recent years, influencing many fields of research and development, such as optoelectronics, biomedical, and photoelectric solar cells, to name a few. We are going to discuss what are nanomaterials, what is nanoscience, what is nanotechnology, why nanomaterials are special, what are the peculiar properties of nanomaterials, how they are prepared, what are the special features and applications of nanomaterials, and so on. What are nanomaterials? Materials having at least one dimension in nanoscale are called nanomaterials. Nanoscale means 0 to 100 nanometer. 1 nanometer refers to 10 power minus 9 meter, that is 1 billionth of a meter is called nanometer. Materials having 1 to 100 nanometers are called nanomaterials. Nanoscience is the study of properties of nanomaterials. What is nanotechnology? It is a multidisciplinary area of applied science and engineering that deals with design, fabrication, characterization, and applications of nano-sized materials and devices. Nanomaterials are classified into three types based on the dimension in which they are in nanoscale. They are 0-dimensional, 1-dimensional, and 2-dimensional. If all the three dimensions, that is X, Y, and Z, are in nanoscale, then they are called 0-dimensional nanomaterials. If only one dimension is in ordinary scale and the other two dimensions are in nanoscale, then they are called 1-dimensional nanomaterials. Examples of 1-dimensional nanomaterials are nanowires, nanofibers, nanorods, nanotubes, nanobelts, and etc. If two dimensions are in ordinary scale and only one dimension is in nanoscale, then they are called 2-dimensional nanomaterials. For example, thin films, thin layers, thin coatings are 2-dimensional nanomaterials. Why nanomaterials are special? How they differ from ordinary bulk materials? Because of the large surface to volume ratio, nanomaterials have special characteristics when compared with ordinary bulk materials. When the particle size decreases to nanoscale, the total surface area to volume increases and therefore almost all the properties change. For example, optical properties, electrical properties, structural properties, chemical properties, thermal properties, electrical properties, electronic properties, even mechanical properties change drastically when the size of the material is reduced to nanoscale. Moreover, when the size of the particle is reduced to nanoscale, the energy levels of electron change. This effect is called quantum confinement effect. Let us consider a tube of size 3 centimeters. Then the area of the square is 3 into 3 centimeters square, that is 9 centimeters squares. Therefore, the total surface area of the 6 faces is 6 into 9, that is 54 centimeters square. The volume of the cube is 3 into 3 into 3, that is 27 centimeter cube. Therefore, the surface area to volume ratio is 2, 54 by 27, 2. When the size of the cube is reduced to 2 centimeters, with all sides 2 centimeter, then the surface area is 2 into 2, 4 centimeters square. And the volume is 2 into 2 into 2, 8 centimeter cube. Therefore, the surface area to volume ratio is 3. That is, surface area is 24. That is 4 into 6, 24. And the volume is 8. Therefore, the surface area to volume ratio is 3. If the side is reduced to 1 centimeter, then the total surface area is 6 centimeter square and the volume is 1 centimeter cube. Therefore, the surface to volume ratio is 6. This clearly shows that when the size of the material is reduced to nanoscale, the surface to volume ratio increases drastically and therefore all the properties change drastically. That is, greater the surface area, greater the reactivity. Materials having large surface to volume ratio exhibit extremely fascinating and strange properties when compared to ordinary materials. Properties like color, conductivity, electrical and as well as thermal conductivity, melting point of nanomaterials are drastically different from that of their bulk counterparts, that is bulk materials. Thank you.
ஓகே சார், நானோ மெட்டீரியல்ஸை வந்து இது மாதிரி 0 டைமென்ஷனல், 1 டைமென்ஷனல், 2 டைமென்ஷனல் இப்படி தான் கிளாஸிஃபை பண்ண முடியுமா? வேறு ஏதாவது மெத்தடில் கிளாஸிஃபை பண்ணலாமா?
பண்ணலாம். Based on the dimension in which they are in nanoscale, they are classified like this: 0 dimensional, 1 dimensional and 2 dimensional. Based on the composition of the material, they can also be classified as carbon based nanomaterials, ceramic nanomaterials, metal nanomaterials, semiconductor nanomaterials, polymeric nanomaterials and lipid based nanomaterials. அதாவது அந்த nanomaterial எதால ஆனதோ, the material with which it is composed of, அதை வச்சு நம்ம இப்படியெல்லாம் பிரிக்கலாம். கார்பன், செராமிக், மெட்டல், செமிகண்டக்டர், பாலிமர் அப்படின்னு பிரிக்கலாம். அப்போ அப்படியும் கிளாஸிஃபை பண்ணலாம்.
ஓகே சார்.